This is Unit 6, Chemical Bonding. Lesson 1, Types of Bonds. How are substances formed from individual atoms? The objectives for this lesson, I can identify whether a bond is being broken or formed based upon the energy being absorbed or released. I can distinguish between the three types of bonds and decide which type of bond is present based upon the atoms involved. And I can classify a substance as ionic, covalent, or metallic based upon its properties. Do now. So, what is a bond? A bond is defined as the force of attraction between two atoms. The energy stored in a bond is called the potential energy. So, why do atoms bond? Atoms bond together to get a full valence shell of electrons to become stable. This is our stable octet. The exception is hydrogen can only have two, which would make a stable duet. And the same goes for helium. Helium is two as well. Breaking a bond, energy is absorbed, which makes it endothermic. I'm taking energy in. The stability decreases. Ripping two atoms apart requires energy. So when I break a bond, I have to put energy in to rip it apart. To form a bond, energy is released. So it's exothermic. Energy is exiting. And this is spontaneous. This occurs spontaneously. This forms a stable compound. For example, like we saw in our video, when we add sodium metal and chloride gas, we produce sodium chloride. The two together makes a stable compound. The way you're going to remember these two differences is BARF. Breaking bonds absorbs, which requires energy, and the release of energy when bonds are formed. So breaking bonds absorbs, the B and the A, and the release of energy when bonds are formed. Three types of bonds: ionic, covalent, and metallic. Ionic bonds occur between metals and nonmetals. This involves the transfer of electrons from the metal to the nonmetal to form a bond. For example, sodium reacts with chlorine. Sodium transfers its one valence electron to chlorine's seven valence electrons. So now both ions are stable with a full valence octet. Ionic compounds are very hard. They have a crystalline structure, like kind of cubic. They have a very high melting and boiling point. They are soluble in water, which means it dissolves, and they can conduct electricity only in solution. So when I dissolve sodium chloride in water, it's now aqueous and now conducts electricity due to the mobile ions. And recall, ions are particles with a charge. And we know this because we can actually do a conductivity test for water by itself, distilled water with no ions. When we put this little light bulb connected with the conductors here, the light stays off. And if we look in this middle, this is solid salt put together. The light does not go on, so the ions are trapped in that crystal lattice structure. Therefore, they do not conduct a current. However, when we dissolve those salt crystals in the water and form a sodium chloride solution, now those mobile ions can conduct electricity and the light turns on. An electrolyte is defined as a compound that separates into ions in solution and is able to conduct electricity. We have a lot of electrolytes in our Gatorade and Pedialyte. They help us stay hydrated. Covalent bonds occur between a nonmetal and a nonmetal, and this involves the sharing of electrons to obtain a full valence shell. That makes them stable. This is how we form molecular substances. The trick to remember sharing is caring. So sharing the electrons is caring, the C for covalent. So why do they share instead of transfer? In a covalent bond, each element is not strong enough to remove or steal an electron from the other one. Therefore, in order to fill those two shells from both atoms, they'll share. So here the electron experiences a force of attraction from both nuclei. The two particles are held together by the negative and positive negative pull. Properties of covalent compounds. They are very soft. They have low melting and boiling points due to weak attraction between the molecules, and they do not conduct electricity due to a lack of charged particles, those ions. A metallic bond occurs between metal atoms of the same element. So, for example, all of the atoms in my gold ring are a metallic substance. There's just gold atoms there, and they're held together by those metallic bonds. Metals have very high melting points and high boiling points because the bonds are strong. They are always capable of conducting electricity because of the mobile electrons freely flowing. This is also called the delocalized electrons. So I mentioned this in the last unit, the sea of mobile electrons. Oh, here it is, the sea of mobile electrons. So, for example, when I have all my metal ions, these positive circles here are the nuclei, and these little yellow circles are the free electrons from the outer shell of the metal atoms. They're kind of like a collective unit. When all those metal atoms get together, they basically share all their electrons. So when I put an electric charge on one end, those mobile electrons can take that electricity and take it out the other end. So that's how metals are able to conduct electricity. So what type of bond is created in each of the following? So here are the results of that. The first one is an ionic compound, an ionic bond, because I've got a metal, potassium, combined with bromine, which is a nonmetal. The second one here is a covalent compound or a covalent bond, and creates a molecular compound because hydrogen and iodine are both nonmetals. Nitrogen monoxide, the nitrogen and oxygen are both nonmetals, therefore it's a covalent bond forming a molecular compound. And the lithium and the chloride, lithium is a metal, chloride is a nonmetal, so that forms an ionic bond. So check your understanding, review your notes, and see how you understand this concept. And by now you can identify whether a bond is being broken or formed based upon energy being absorbed or released. Remember BARF. Distinguish between the three types of bonds and decide which type of bond is present based upon the atoms involved, and classify a substance as ionic, covalent, or metallic based upon its properties.